solution where they all keep their properties?
Excellent. A solution where they all keep their properties. So there's a lot of particles in the blood. We have red blood cells, we have white blood cells, we've got proteins, we've got a lot of things that are in the blood. So they're creating a pressure at this membrane level. NFP, net filtration pressure. This is how the body works to maintain the pressures in the glomerulus. Whether we're looking at the pressures outside of that glomerulus versus inside. Your textbook gets into a little bit of math and so forth. I'm not asking you to do that. I'm asking you to understand that net filtration pressure, NFP, is a balancing between the pressures for this glomerulus. So if we look at the forces for this glomerular filtration, this first step, this is the math, okay? Not asking you to understand that, okay? We have a blood hydrostatic pressure, a colloid osmotic pressure. We have a pressure in the capsule, okay? Under normal conditions, they have determined what an NFP would be, a net filtration pressure. I want you to understand, NFP is a balancing act between these pressures. Ones that are inside those capillaries, ones that are outside those capillaries, internal versus external.
Is it a balancing act inside?
It's a balancing act all the way around. Whether we're talking about this blood that's moving through these capillaries, which would be in that blood, okay, or what's going to be outside it, outside of those capillaries, it's a balancing act between the inside and the outside to get a net filtration pressure. High blood pressure definitely affects this region. This region can adjust to a low blood pressure, okay? But blood pressure drops too low, lots of other things can go wrong in the body. But the biggest factor affecting the glomerulus would be a high blood pressure. An untreated high blood pressure would be very detrimental to the glomerular capillaries. So what we say is that there is a normal amount of filtrate that should be produced per minute. And this is termed glomerular filtration rate. A normal amount that should be produced per minute. In the normal healthy male, about 125 milliliters per minute, or about 180 liters per day. Okay, stop right there. What is that telling me?
Our blood is filtered many, many times during the day.
For the males, there's more filtration rate.
Excreting.
Say that again.
We're not excreting very much.
So, for the female, okay, I don't know about y'all, But if I had to get rid of 150 liters per day, I wouldn't be standing here right now. How about y'all? Okay? And we'll pick on Isaiah because he's our only guy in the class. Isaiah, could you get rid of 180 liters per day?
Yeah, probably.
Probably. There you go. That's what I'm talking about. That's what I'm talking about. So, the filtrate that goes through these microscopic structures, we generate, I don't know about y'all, a lot per day. But note, about 99% gets reabsorbed, and we produce about 1 to 2 liters per day. That's the norm. This process of creating this filtrate has to be very closely controlled. If we have it too high, that means the flow through these tubes, through these glomerulus, okay? The flow is too quick. Our urine output increases. It could lead to possible dehydration and depletion of very important materials that the body needs. If it's too low, we don't have enough moving through the filtration processes, we're going to absorb too many wastes back into the body. It could lead to something called azotemia. Azotemia are those nitrogen compounds, the stuff we really need to get rid of, okay? Those nitrogen compounds can get back into the body. That could lead to uremia, which means urea in the blood, and that could mean death. So this process, it has to be very closely regulated. So how do we regulate it? We regulate it with auto-regulation. What does auto mean?
Without control.
It's automatic. So basically, the nephrons can adjust their own blood flow. This will help keep the rate stable if arterial blood pressure rises. So that tells me if my blood pressure out here rises, those nephrons in my kidneys can control that, because if the blood is under high pressure, okay, we're getting a little bit more movement and so forth, and that would mean more pressure into that capsule, into those capillaries, that the nephrons themselves can control that. Does that make sense? Yes, no, maybe. This will help make sure that we maintain electrolyte balance. The myogenic. Myo is what? Muscle. All right? If blood pressure goes up, remember, when we talk about the vessels of the body, are they not muscle? Smooth muscle? Okay? If the blood pressure goes up, the afferent arteriole stretches. That is going to make the arteriole constrict, affecting the flow, meaning it doesn't want to allow that larger pressure, that larger amount under pressure to come in. It's trying to control it. But now if the blood pressure drops, well, this arteriole, it needs to relax because we're going to need to get the blood flow through the kidneys, through the nephrons. So it has a way to affect the flow at those arterioles. Then we have tubuloglomerular feedback. Information from the tubes and the glomerulus. It uses something called the JG apparatus. Anybody done their reading? Juxtaglomerular apparatus. Don't worry, I got a picture. This one is at the end of the nephron loop. Information is given about the tubular fluid so that we can adjust the blood flow into the glomerulus. This is what it looks like. What you think? So, blood flow in, blood flow out. All right? Note this apparatus right there. Okay? Note, remember how I said those nerve fibers reach to the vessels of the nephron? Where are they reaching? We have them go all the way to the vessel of the nephron. And if you remember, it's sympathetic innervation. Haven't mentioned anything about parasympathetic. Sympathetic innervation. So, we can have information be sent about this tubular fluid, okay, the glomerulus, and we can control the rate of the flow through the glomerulus. This juxtaglomerular apparatus. Yes, no, maybe. Looks like an area sitting in between the afferent and efferent arterioles. Area of cells. If the rate rises, meaning trying to get more blood flow into that glomerulus, sodium chloride reabsorbed, okay, we're going to see that we need to constrict that arteriole. We need to make it do this number so that we don't have this high pressure moving into the capillaries, because if we have that high pressure move into these capillaries, flow is going to be coming too quick. We're not going to get proper filtration, okay? And it will affect the urine output. If we have the flow decrease, we have blood pressure decrease, this can open up and allow blood flow to come back in. We still get the filtration. Everything seems to, you know, go into a little bit of relaxation, okay? And we can go on to produce the urine as needed. Yes, no, maybe.